Hey, it's Mr. J, and I'm making some videos. This is for our number on whole units, whole numbers, and we're looking at all the operations with whole numbers, so addition, subtraction, multiplication, and division. And this first video is kind of important because it brings a question of why are we looking at all these different ways to solve these questions. And for your parents and for me when we were kids, we, got a piece of paper with 100 questions on it, and we did 100 of them. We raced to see who was the first done, and you stood up, and how many can you do in a minute? And there's a lot wrong with that. So, number one is that, if you didn't finish first or second, you didn't feel very good about number sense. You didn't feel very good about yourself or about how you could work with numbers. And also, we didn't treat the numbers properly. We lost track of their value, and I'll give an example. So we'd get a sheet, and it would have, like I say, 100 questions, 200 questions, a textbook filled with 1,000,000 questions. It'd be numbers like that. So it'd be 12 plus, 39 or something. And they'd always be lined up this way, always. One number stacked on top of the other, and then you'd add them up. So you'd say, okay, 9 plus 2, well, that's 11. So I put the 1 there, and then I don't ever want to put the other 1. So I'll put it up here, and it's kind of working. And then I go, okay, 3 plus 1 and another 1, that's 5. So the answer is 51. That's true, and it worked, but there's a lot wrong here. First of all, when I said 9 plus 2 is 11, I put the 1 here, and I put a 1 here, and I said I'll put the 1 here, and then I'll add the 3 and the 1 and the 1. That's 5. That's true, but this is not a 3. This is not a 1. And that's not a 1. This is 30. And that's 10. And that's 10. You lose track of the numbers when you do this, and you lose track of their value, how big they are, how small they are. Treating this as a 5 is not right. It's 50. It's in the tens column, so the standard sort of North American algorithm is to work with the tens and the ones and on, always going up by a multiple of 10 and down. So there's a lot good there, but this is really the sticking point for me as a math teacher, is losing that value. And you can see how silly it gets when you do something like 11 take away 9. So this is the one I always use with kids. Okay, 1 take away 9. Well, I can't do that. If I've got 1 of something, I can't give 9 away. So get rid of this, because that's a 10. So we're going to borrow, whatever that means. Like, you're going to pay it back? I don't know. So that's 0. And I take the 1 here, which again isn't a 1, but whatever. And I put it here, and now it's 11. Okay. And I got 11 take away 9. It's what I had at the start. But anyways, it's 2. It's kind of a silly example, but there's lots of them. What about 2,000? Take away 1. I'm going to line that up. No, I can't do that. I can't borrow from the tens, the hundreds, so I go all the way to the thousands. I cross at the 2, which is not a 2. Put a 1 there, and then put a 1 there, and then cross at the 10, which again, it's not a 10. Put a 9, not a 9. Keep going down the train. Whew, finally did it. And, so there I go. Okay, so that's 9. And I got 9 take away nothing. 9 take away nothing. 1, whew. A lot of work to get the answer to a question that I knew without having to do it. Silly examples, but they all kind of make the point of why we're going to learn some other ways. I'm going to show you other ways, don't worry. So in grade 5, we do questions with numbers like 23 times, let's just do 2 23s. And so the way we learn them as kids is we stack them up and start multiplying. There's all kinds of silly things that go on. So 3 times 3 is 9, 3 times 2 is 6, and then you put a 0 here. Why? I don't know, because I was told to, so I put a 0 there. So there's a 0. The reason why is because we're trying to move the place value over 1, but I didn't understand that when I was in grade 5 or 6 or at any other point in my schooling. But yeah, so you put a 0 there. Okay. And then we're over here for some reason. 2 times 3, again, it's not 2, it's 20, but anyways, 2 times 3 is 6, and 2 times 2 is 4, and then I'm done. So I put a 9 here, and then a 2 here, which is not a 2, carry the 1, which is not a 1, and there's my answer, 529. So, it works, but you forget the 0, or you don't line something up properly. There's a lot of chances to make a mistake. I've taught lots of grades, lots of math, and this is a killer when there's this empty space here. So I hope that kind of explains the answer why, is because when you see the other strategies I'm going to teach you, you're going to see that we're really looking for number sense. I mean, that's what it's called in the report card, number sense, an understanding of numbers and how big they are. And the standard North American algorithms, don't do that. They do a really bad job of the number sense, the value of it. And that's why kids have such a hard time when they get to grade 7, 8, and they start working with fractions and they start working with decimals, is because they're used to treating a 5 like it's a 5, and this isn't. This is, 500ths. It's a lot different than a 5. So that's the reason we're doing this. We're kind of big picture in math now. If you introduced me to some child who'd never learned math and said, teach them how to multiply, you've got, 3 days, I would teach them this standard algorithm because it's fast and it works. And it's, pretty easy because you're always working with small numbers that you're multiplying. But it's not the best way, and it doesn't translate well to decimals and to percentages and things like that. So I hope as you see the other strategies and as we work with them in class, I hope you'll agree with me, and if not, that's okay. You can go back to this one. So yeah, first up, addition.